So again, as we did yesterday, we're going to kind of like start just here at the top. We're not going to go through the explore, okay, just kind of save on time, especially since we're short today. All right. But angle relationships in circles we're going to talk about. We already know some angle relationships, right, and how they relate to arcs. For example, we know that central angles, right, are equal to the arcs that they intercept or cut out, right? Inscribed angles are half of the arc or the intercepted arc or the arc that they cut out. Okay. We also have some new relationships we're going to look at today, between angles and arcs. Okay. So what are the relationships between angles formed by lines that intersect a circle? Okay. So again, we're not going to do the explore here. We're going to jump right over to the next page, at the bottom on page 830, and we'll take a look at this. Excuse me. And we're not going to prove it. We're just going to talk about it here. Excuse me. So you'll see a similar scenario to what we saw yesterday, okay? Except in this case, we are not talking about these segment lengths, okay? We're talking about angle measures here. Specifically, okay, if two secants or chords intersect in the interior of a circle, so here you can see we have two chords, or these could be like parts of a secant line too. So if you have two secants or two chords that intersect in the interior of a circle, right, they intersect right here inside the circle, then the measure of each angle formed is half the sum of the measures of its intercepted arcs. Okay? So again, that's kind of a bit, here, but let me kind of show you what that means. So for example here, they have this angle 1 identified. This angle 1 is equal to 1/2 the sum of arc AB and arc CD. Okay, so if you add up the measure of arc AB, this right here, and you add the measure of C with the measure of CD, divide that by 2, that'll give you the measure of angle 1 here. Okay? Now keep in mind, right, if this angle is angle 1, what would the measure of this angle have to be? The same thing. Why? Because they're what? They're vertical. Yeah, okay? So you can really think, okay, I do have two angle 1s in this problem. I have an angle 1 here, and then vertical to it, I also have an angle 1 right here. And so you can see, aha, these angle 1s they're cutting out two different angles. Or sorry, arcs. Arc AB, they're intercepting, but also arc CD, they're intercepting as well, okay? And so we can, again, add AB and CD's measures up, okay, add them up, and then divide by 2. And that'll give you the measure of angle 1. Okay? How can we find the measure of, like, this angle right here, angle BED? How can we find the measure of that angle once we have angle 1? 180 minus angle 1, right? These are going to be supplementary, or 1 and this one will be supplementary, right? And then once you have this angle, you also have this one because they are vertical to each other. Okay? So, that's a key relationship right there. All right? Angle 1 is 1/2 the sum of the two intercepted arcs there. Okay? So let's try. And again, we're not going to worry about proving it. We'll just kind of jump into some problems here. All right, so let's look at, oh, they don't really have anything except for the proof. All right, well, we'll do one of these we'll do the our turns, or your turns together here. Okay, so let's take a look here at this first one. All right, we're trying to find the measure of angle MPK, which is this angle right here. I'll call this angle 1. I'm just going to label it angle 1 there for ourselves, which also means that this is angle 1 as well. Okay, and so angle 1, the intercepted arcs here are the 111 and the 61. So the measure of angle 1 is 1/2 61 plus 111. Okay, these two intercepted arcs. Okay, so let's see, that's going to be 172. We add those up, right? Yeah. Okay, and then half of 172. Let's see here, 86. Okay. So we'd expect angle 1 to be 86 degrees. Or in other words, the measure of angle MPK. Okay, 86 degrees. Bless you. All right, let's try this next one here. Now this next one, number 5, we're trying to find the measure of arc PR. So I'll just call that X right here. Okay. Now here you'll notice we have the angle. We have the angle. We have one of the intercepted arcs, 82, but we don't have the other one right here, x. So how should we go about setting this up? Well, 58 degrees is our angle, and that's got to equal 1/2 82 plus x, right? The two intercepted arcs added up times 1/2 should equal that angle there, 58. Okay, so we're going kind of like backwards a little bit here. How should we go about solving then from here? What should we do to both sides? Or what should we do here? Yeah. Okay, so we can undo that times 1/2 if we want to multiply both sides by 2. Did anyone want to say distribute the 1/2 here? So alternatively, you could also distribute the 1/2. So I'll show you kind of both ways here. Let's do Jenny's method. We'll multiply both sides by 2 first. So that's going to give us 116 degrees equals 82 plus x. And at that point, you can just subtract 82 from both sides. So you get x equals 34 degrees. Okay, that way. Or if we distribute the 1/2, we get 58 degrees equals 41 plus 1/2 x. We'll subtract the 41 from both sides, and we get 17 degrees equals 1/2 x. Now we'll multiply both sides by 2, and x is again 34 degrees, because 17 times 2 is 34 degrees. So either way, get the same answer there. But yes, 34 degrees then would be this arc measure. Oops, I'm off the screen. There we go. Okay. Questions on any of that? So again, taken alone, right, if this was all I asked of you, right, then this would be super easy to remember. But you'll have to remember this along with all the other relationships that we've talked about, right? And that's where it gets tricky, okay? I won't be able to give you these as formulas or any sort of formula sheet or anything like that on the test, right? You'll need to remember these relationships. You'll need to remember these relationships. All right, turn the page there. All right. What two kind of segments do we have here? What can we call this? BC is a what? Looks like it's going to intersect the circle at one point, so we could call it a what? Tangent. Tangent intersects at one point. And then what would BA be? It's 2 points. It intersects a circle, so that would be a secant. Okay? So here we have a tangent secant inter-angle measure theorem. Okay? So again, I'm not going to read through this whole thing here. I'll just go cut to the chase here about what we're trying to find. The measure of angle ABC, ready for this? The measure of angle ABC is 1/2 the measure of arc AB, that intercepted arc there. Now what does that sound like? Inscribed angles. Where's the vertex of this angle located? Where's the vertex of this angle located? Yeah, on the edge, on the circle, right? Where's the vertex for an inscribed angle located? On the circle as well, okay? So, in summary, if you've got an angle and its vertex is on your circle, okay, then that angle is 1/2 of the intercepted arc that it cuts out. So you can think of this like an inscribed angle. This angle right here is 1/2 of this arc that it's cutting out, okay? Just like right here, angle ACB, that's an inscribed angle. This angle is 1/2 arc AB, okay? Or BCD, this angle right here, angle BCD, that is 1/2 the arc 142 that it cuts out there, all right? So if your vertex of your angle is on the circle, that angle is 1/2 of the arc, intercepted arc that it cuts out there, okay? So let's take a look. Now I've got some examples to kind of look at here, all right? So for letter A, all right, the measure of angle BCD, all right, so BCD, well, this angle right here is cutting out 142, right? So angle BCD will be 1/2 arc BC. And so you can see there's the 1/2 times the 142, and so you get 71 degrees there. So this angle right here is 71 degrees. Okay. Well, what about the measure of arc ABC? Okay. What does it look like it's going to be? What will the measure of arc ABC, what does it look like it's going to be? It looks like it's going to be 180, right? But we can also check that. The measure of angle ACD, right? So ACD cuts out this part of the arc. Okay, we know angle ACD is 90, which is then equal to 1/2 the arc right here of ABC. And so we'll multiply both sides by 2, and you get 180 degrees. Okay? Question, Jenny?
Could you also find the measured angle, or the measured angle, other part of ACB?
Yes. So since we know that angle BCD, if from here to here, is 71 degrees, then we could subtract that from 90 to say that this is going to be, what, 19 degrees? Okay? I think that's right, right? 19 plus 71? Yeah. Okay, and then so if angle ACB is 19, how can we get arc AB? What should we do? Multiply by 2. 19 times 2 is 38 degrees. And 38 plus 142? 180 degrees. 38 plus the 142, there would be 100. So yes, there's more than one way to do this. More than one way. In some cases, some situations, okay? More than one way. Okay? And of course, the more kind of stuff, like here again, it's like kind of like there's only one angle, there's this circle, but here there's like, 1, 2, 3 angles, there's a circle. So again, it can get kind of confusing the more stuff that's thrown in there, okay? So that's why it's really important you have these relationships down so you can get those, you can understand those and stuff like that. So, all right. So why don't you guys go ahead, try 6 and 7 since we got a chance to work on some on our own. Why don't you guys go ahead and try 6 and 7 there. We're on page 832 there, Matty G, just so you want. Mm-hmm. Thirty more seconds here. 30 more seconds. Okay. 30 more seconds. Yes. Yes, go ahead, Steve. Okay. Let's go to, someone who's here. All right, Madison, did you get an answer there for number 6?
I said 122.
122 degrees? Sounds good to me. How'd you get that 122? What did you do?
I did 360 minus 238.
Okay. Yes, that would work here. What else could we have done here? Did anyone solve that in a different way? So yes, certainly here, zoom in too much, there we go. Okay, certainly here, yes, if we know that this arc on our circle here is 238, the remaining part is going to be that arc PN, so 360 minus the 238 will give us that measure of 122. But, yeah, Avery?
I multiplied 61 by 3.
So alternatively, we also have a angle right here, okay? It is kind of like, again, I don't want to say it's inscribed. It's a tangent secant interior angle. That's a lot of words to say, but essentially its vertex is on the circle. The measure of the angle is 61, and so that means the arc that it cuts out, the intercepted arc, is double that, 122. Okay? Alternatively. But that's great, though. Also good. All right, pretty good, Madison and Avery. Thank you. All right, how about Grace? Were you able to get number 7, Grace? Hello. I have a meeting, yes? Yes. Okay, very good. You don't want to answer the question? You don't have it? Okay, so let's take a look here. Angle MNP. Okay, this is the angle that we're trying to find that measure. Okay, the arc that it intercepts, this arc, which is what measure? What's that? What's the measure of it? 238, right? Okay, so this angle then is going to have to be half of that. So we're just going to do 238 divided by 2, and you end up with 119. Okay, I did it already there for you. Okay, so it's half of the arc that it cuts out. Okay, half the arc cuts out. Questions on any of that? All right, I have to run to a meeting right now, so what I'm going to do real quick for you guys is I'm going to give you, I guess, your homework assignment. There are a couple more relationships here that we didn't get to talk about, okay? But you can figure them out, I think, okay? And if not, I'll come back and we'll talk about them. And if not, we'll talk about it tomorrow some too. But you'll notice that all of these scenarios, right, the angle is outside of the circle, okay? So when the angle's outside the circle, you'll notice some similarities. It's 1/2, right? They all have a 1/2. So each of these angles here, angle 1, angle 2, and angle 3, they're all 1/2 the difference of the two arcs they cut out. Okay? Big arc minus little arc, obviously, here. So this angle right here is 1/2 the difference of this arc minus this arc. Angle 2 here is 1/2 the difference of this arc minus this arc. And angle 3 here is 1/2 the difference of this arc minus that arc. Okay? That's the idea. And if you want a nice summary, on page 834, there's a nice summary of the 3 scenarios we have. If your vertex of your angle is on your circle, then this is what you do. If your vertex of your angle is inside the circle, this is what you do. And if it's outside, this is what you do. Okay? So if I come back, we'll go over that with some more, we'll go over that some more. But in the meantime, let me get you guys started on your assignment here. Okay? So starting on page 836. Okay. I'll just have you do 3 through 13. Okay. And then do I want to add anything else there? All right, we'll just do it there. Okay. So 3 through 13. I'll just give you those. All right. And of course, there's your TenMarks too. TenMarks as well. All right. Thank you. So. Oh, okay. Okay. That should be easy then. Thank you. Okay.